Alright, finally, we're getting closer and closer to programming. In the last video, we talked about the ROM and operating systems. Now then, in this video, we'll be looking at programming languages. We'll start off with the simple question of what is a programming language, then we'll talk about what low level and high level means, we'll go into compiling and interpreting, and then we'll discuss what programming language we're going to be using in this series. And this is the last full theory topic. In the next video we'll be looking at Visual Studio, and then we will be ready to start programming. Okay then, let's start off with the obvious question of what is a programming language. Well, there are lots of different ways of telling the computer how you want something done. And so a programming language is the way that you tell the computer what you want it to do. On the screen are 3 different programs, written in 3 different programming languages, C# and Java. Each of these programs do exactly the same thing, but you can see that they're different. That's because each programming language has its own rules and its own way of doing things. There are also 2 main types of programming languages, or I suppose 3 if you want to have one in the middle. Low level and high level. So what does that mean? Well, luckily I've basically already explained it in the last video with an operating system. Really low level programming languages are where you talk straight to the computer. So it's kind of like there is no operating system. You are talking straight to the computer, and as I said in the last video, even doing simple tasks requires a lot of work. So then, what are high level languages? Well, of course, it really wasn't ideal having to do so much work yourself. And so, we started developing languages that are closer to English and easier to understand. Look at these 2. One is a really low level language, and one is a pretty high level language. Look at how much more understandable the higher level language is. You can see just by looking at it that it's got the text hello world in it, and that it's writing that somewhere, like perhaps on the screen, whereas in the other one you have no clue. You can see the text hello world, but it will take a very long time to work out what it's doing with that text. In addition to being easier to read, higher level languages also tend to do quite a lot of the work for you. So, for example, in many high level languages you can create things called objects. So if you have 4 objects, the language itself will automatically put that object in an empty space in RAM, and it will automatically remove that object from RAM when you're done with it. There's also one other major advantage to high level code. Remember when I said that different CPUs have different architectures? Well, when you write low level code, that code will be different for every single architecture. So if you wanted to write code that runs both on a computer and a phone, not that you would be writing low level code on the phone, you would need to write the same thing twice for both x86 and ARM. Whereas with a high level language, it will most likely work on both. There are of course disadvantages to using high level languages. They tend to be considerably slower in speed than writing it all low level, because they do a lot of extra stuff in order to help you write code easier. But generally, nowadays it really doesn't make a difference, you wouldn't even notice it. There's also the disadvantage that some programming languages, kind of like the one we're going to use, rely a lot on the features provided by the operating system, in our case Windows. And as you know, there are more operating systems than just Windows, which means that in order to run our programs on other operating systems like Linux, you essentially have to run it in a special environment that pretends to be Windows. Okay, fine. So, high-level languages have advantages and disadvantages. But there's still one major question. How do computers understand high-level code? The only code that computers themselves understand is machine code, which is the lowest level you can get to, and that's just binary. Whereas, when you write high-level code, it's just text. When we start writing code, you have to understand that the code we're writing is just text. There's nothing fancy about it. You could write a whole program in Notepad if you wanted. So, how do we go from this text to actual binary code that the computer can understand and run? And there are two methods of doing this. The first one is compiling. A compiler is a program that will take all of your code, which is, once again, just text, and convert it into actual runnable machine code for you. Then it will pack it up in something like an exe file, and there you go. You can just double click on that exe file and your program is running. The second method is interpreting. So with interpreting, your program basically stays as text. It never actually gets converted to machine code. So we use a program called an interpreter, which is lower level than the language it's interpreting. Same goes to the compiler actually. And what then happens is, when you run the program, the interpreter will basically read through the text and then just do whatever the text says. So, if the code, or text, says to write hello world to the screen, the interpreter will see that, and then the interpreter will write hello world to the screen. If the next line said to write onto the screen what 2 plus 4 is, then the interpreter will take 2 and add 4 to it, and then write that on the screen. Hopefully you can see what's going on here. Basically, instead of converting the program into low-level code, we get a lower-level program, the interpreter, to basically do whatever our code says for us. So, if our code says to put hello world on the screen, the interpreter is going to go ahead and do everything it needs to, and it will write hello world on the screen. Notice how at no point there did our code get converted to machine code. The interpreter itself is probably machine code, otherwise how would it do all these things? But our code doesn't actually get converted, it just stays as text. An interpreter is a program that goes through all your code and does whatever your code says to do. Whereas a compiler will take all of your code and convert it to machine code, which the CPU, or more specifically the control unit, can then go through and run. And there are advantages and disadvantages to both methods. The advantage of a compiler is that it's faster than interpreting, because your computer is getting turned into machine code, and it's being ran by the CPU itself. There's nothing in between the CPU and your code slowing it down. However, interpreting also has some advantages, one of them being that it can be more secure. Because your code never gets converted into machine code, that means that everything your code tries to do will go through the interpreter. And if the interpreter doesn't like something you try to do, it technically could just not let you do it. This means that if someone really wanted to, maybe for security reasons, you could theoretically completely prevent an interpreted program from actually modifying or even looking at your computer's files and whatever. And actually, many mobile apps are actually run like that. You have to allow them to do these things. Otherwise, the interpreter would just block them from doing them. Oh, and here's another advantage for interpreting. You know how earlier I said that high-level code can work on lots of different architectures? Well, when you're compiling, you have to manually compile the program for each architecture you want to support, and you may be using lots of different compilers to do that. Whereas when your code is interpreted, your code can run anywhere, provided it has an interpreter that is written for a specific architecture. There's a programming language called Java. It was created because there was a bit of a problem with low-level code. If you wanted to have a program that would work on lots and lots of different devices, you would have to either rewrite the code a whole bunch of times for each architecture, or you would write it in a high-level language and compile it a bunch of times for different architectures. And if a programming language didn't have a compiler for a specific architecture, then you're out of luck. But Java came with a different approach. This is essentially how Java is run. Oh, and by the way, Java wasn't actually the first to do this, but it was extremely popular. Java came with the idea that instead of converting it into low-level code for every single architecture, you could have an interpreter. Now, this is actually a very good idea. especially back in the time when there were a lot of different architectures. The idea is very simple. The people behind Java make an interpreter for a specific architecture, let's say x86, and there you go. That's it. All Java code will run on x86 processors. They don't have to be especially compiled or anything, they will just work on x86 processors. Oh look, a new architecture called ARM came along. Let's just make an interpreter for that, and there you go. Now, all Java code works on ARM processors, and so on. The point is that as long as a language has an interpreter for a specific architecture, your code in that language will run on it. And that is a major advantage, because programming languages like Java are so popular that it probably has hundreds, maybe thousands of interpreters for all kinds of different architectures, and you don't even have to do anything. It will just work on all of them. So this brings us on to the final question. What programming language are we going to be using? Well, it's called C#, and yes, that hashtag there is pronounced sharp, C#. So, C# is a high-level language. We are not writing low-level code in this series. Maybe as a bonus part at the end, but really, we're not writing low-level code. We're going to keep things simple here. Now, C# is a bit funny when it comes to being compiled and interpreted, since it's kind of both. What happens is your C# code gets compiled, but not to machine code, but to something called the intermediate language. Intermediate meaning that it's sort of, in between high level and low level. And it sticks that IL in an exe file, and that IL then essentially gets interpreted when you run the exe file. I know it's really odd, but obviously they did it so that it could run on multiple architectures, but just to keep things simple, let's just think of it as being compiled, even though it is kind of interpreted. Okay, let's summarize all of this. A programming language is a way to tell the computer what you want it to do. Higher level programming languages are easier to write in and do a large majority of the work for you, whereas low level programming languages require you to do a lot more work. Now, CPUs only understand low level code. They don't understand high level code. It's way too close for English for them to understand them. So, how do CPUs understand high level code? Well, there are two methods of getting CPUs to run high level code. The first one is compiling it. This means you put the code, which is just text, through a compiler, and it turns that code into binary code that the CPU can read through. And technically, the control unit is interpreting that machine code. But when we say interpreter, we usually refer to a program that's been compiled just like any other program, but it reads through our high-level code, or at least an in-between language of some kind. And that is the other way of running high-level code. So, hopefully you now understand what low-level code is about and what high-level code is about, as well as compilers and interpreters. You'll hear me saying things like it's compiling now and low-level quite a lot throughout the series, and that's what they all mean. Okay, in the next video we'll start looking at Visual Studio, which is where we'll be writing all of our C# code. Bye!